Hi, thank you for joining. My name is Crystal Olivaria, and I'm the career conversationalist. And today we're here to talk about understanding nanotechnology and its applications, part 2 of 3. Discover what makes nanotechnology different than other technology. Avoid misunderstanding practical applications of nanotechnology, and learn why carbon at the nanoscale may replace silicon in computers. While you learned what nanotechnology is and discovered why it is a promising career path in the post, What is Nanotechnology? Is it a promising career path? Part 1 of 3. Now it is time to dive a little deeper into the world of exploring nanotechnology. Do you want to better understand nanotechnology to find out if it is something you are interested in pursuing as a career path? Discover what makes nanotechnology different than other technology. The technology easily accessible today is made of material like silicon. Silicon is an element on the periodic table of elements. Multiple elements and molecules are used to make technology devices. Nanotechnology looks at the materials on an incredibly small scale, at the atomic level. Materials at the nanoscale level behave very differently and take on different characteristics. Typically, we are used to materials acting and behaving in one of three ways. For example, we are used to water being able to be a solid, liquid, or gas. Water can be a solid by being an ice cube. Water can be a liquid that you drink. And water can be a gas that is present when you take a hot shower and steam up the bathroom. Or it can be found in nature in the form of fog. When water molecules, H2O, are close to each other, they create a solid, ice. When there's more space in between the water molecules, there is a liquid, water. And when there's a lot of space between the molecules, there is gas, or steam, or fog. Since you are probably familiar with water in the state of a solid, liquid, and gas form, then you probably understand how the water molecule H2O can be different physically forms based upon how much space is between the molecules. Nanotechnology goes a step further because rather than looking at how much space is in between the molecules, it looks at how materials act differently based upon how much material is present. In the 9-minute, 56-second video, What is Nanotechnology? What applications can it be used for? States that, say you go from a crystal that is 100 atoms across to 50 to 25. Each time you do that, almost all the properties of the material really change. These changes are very radical and quite dynamic. If you take a piece of material like silicon and you look at the material, it looks like a dark charcoal. So it is not that interesting to look at. But now, if you take out your little nano ice cream scooper and you scoop out a nano size of that material and you look at that, all of a sudden it glows blue. If you take a slightly bigger ice cream scooper out, it glows red. So now you have a material that completely changes the way it looks and the color that it is just by changing its size. So why do nanomaterials act so strangely? In the case of the nano ice cream scoop, the behavioral changes happen when you make the material so tiny that its electrons are squeezed into a space smaller than they prefer. It's called quantum confinement. The video also states that at the nanoscale, everyday materials begin to act in unimaginable ways. Suddenly, it is like the periodic table projects into a new dimension. It's not just like we have a list of elements. We can change their size, and each size is a little bit different than every other when it is very, very small. In the video, at the 1-minute and 20-second mark, the video shows an image of the periodic table of elements chart projecting out in multiple dimensions. What makes nanotechnology different than other technology is that there's a lot more focus on the materials being used. Understanding the properties of elements at different sizes and how they behave is likely to play a role in deciding which elements are used to create our technology gadgets. Avoid misunderstanding practical applications of nanotechnology. Misunderstanding what happens when there is a lack of understanding. Depending upon what sources you go to, it can be very easy to misunderstand information. For example, a lot of university research is written using scientific and technology vocabulary. If you do not understand the vocabulary, it can be very easy to misunderstand the results of the research. Furthermore, a lot of academic research focuses on the practical applications on the micro level, or the zoomed-in view. Typically, researchers learn about new ways to do things that could have practical applications in the near future. There seems to be a large gap between what is possible someday and what is possible within the next few years. Therefore, the best way to discover practical applications for new technology being developed is to attend industry-related conferences, either live or virtually. In the 14-minute, 18-second video, Nanotechnology Applications, Samsung Smartphones, Yum, Flexible Phone, Samsung Keynote, Brian Berkeley, the Senior Vice President of Samsung San Jose Display Lab, discusses trends have been seeing in the display industry. Just like processors, displays have been involved in an intense competition, in this case, a pixel war. The trend is towards higher resolution. Think about the increased resolution that has allowed you to see images more crystal clearly on your phone, tablet, desktop, and television screen. We are talking about how advancements in technology to see images more clearly is allowing devices to be redesigned to offer more exciting consumer products. The exciting part of the video is the product demonstration of a prototype, a movie being played on a thin piece of plastic that looks like it could be a cell phone. The thin plastic screen is bendable and is being developed so that it can fold as well as allow to roll for rollable screens. As the video states in a little technical jargon, at Samsung, we are equally excited about the possibility of mobilizing OLED display technologies. When it comes to displays, OLED delivers the ultimate screen experience with more vivid colors, as much deeper blacks than any other displays. They are super thin and lightweight because OLEDs produce their own lights. They don't need or require a thick, heavy, power-consuming backlight. Now, thanks to Samsung technology, they can be flexible as well. We are so confident in the market potential for OLEDs, we are creating an entire new line of them under the Yum brand name. Yum doesn't just bend the rules of technology, it completely rewrites them. Prototype demonstration is at the 4-minute, 15-second mark. Take a look at this flexible prototype. Our team was able to make a high-resolution screen on an extremely thin plastic instead of glass, so it won't break even if it is dropped. You can actually bend the screen. Imagine the types of products you can design with this. Later on in the video, Samsung presents an idea of designing cell phones so that the screen can unfold to be the size of a tablet. Then, towards the end of the video, Eric Rutter, the Chief Technical Strategy Officer at Microsoft, talks about technology that will impact the gaming industry. The gaming experience will become more 3D by having images of the game project out beyond the screen and onto nearby surfaces. Eric states that Microsoft vision is that sensors like Kinect combined with flexible, transparent, and projected displays will bring us a point where any object can be a surface and can be a computer. I would like to close with a short video from Microsoft Research which extends interactivity to every surface of your living room. Before the video is shown, the Microsoft employee adds one more comment. at the 12-minute and 30-second mark. Watch out, Apple fans! Some companies talk about a reality distortion field. We have actually built one. Below is a cropped image of from the video. The picture is a dark living room with a screen of a go-kart racing game in the snow, and the snow is projected on the walls and objects of the living room. While these applications are being developed, there's more that needs to be done in order for these products to come to market so that you and I can buy them. For a better overall technical understanding of how the nanotechnology and how it is being used to create higher resolution screens, check out the short 2-minute and 44-second video, Nanotechnology Part 1, Explore the Nanoscale. Learn why carbon at the nanoscale may replace silicon in computer chips. Silicon has been the big buzzword in technology for the past 50 years. Silicon is an element on the periodic table that has played an enormous role in allowing computer parts to process faster and allowing us to use the great applications we enjoy today. In 1965, a company founder of Intel Corporation that has grown to become one of the world's largest semiconductor chip makers observed and predicted the rate of technological growth that has been maintained for the past 50 years. In the MIT Technology Review, MIT stands for Massachusetts Institute of Technology, a highly prestigious university, published the article under computing. Moore's law is dead. Now what? Shrinking transistors have powered 50 years of advances in computing, but now other ways must be found to make computers more capable. The article states that Moore's law is named after Intel co-founder Gordon Moore. He observed in 1965 that transistors were shrinking so fast every year, twice as many could fit onto a chip. And in 1975, he adjusted the pace to a doubling of every 2 years. This law has remained true for quite some time. However, we are bumping up against the physical limits of what is possible with silicon that is currently being used in technology. The article states that Intel has suggested silicon transistors can only keep shrinking for another 5 years. What this means is companies all over the world are trying to figure out how to make computer chips compute at a faster rate using materials besides silicon. It seems like carbon is a likely candidate for a few reasons. Before we discuss these reasons, let's talk a little bit about carbon. The short 2-minute, 40-second video, Nanotechnology Part 2, Nano Properties, states that we are used to carbon as a super hard diamond or soft graphite. At the nanoscale, hollow nanocylinders of carbon can form the highest tensile strength material known, carbon nanotubes. These tubes are made up by rolling up flats of 1-atom thick sheets on carbon called graphene. Bulk carbon is not a conductor, but on graphene, the electrons scoot about like billiard balls. If you then stack these sheets, you can tune the electrical conductivity. This means we could see carbon replacing silicon in computer chips. Carbon on the nanoscale has electrical conductivity properties that are necessary for computer chips. Carbon is likely material candidate of choice because there's plenty of it that is easily accessible for mass production of computer chips. At the time of crafting this post, creating 1-atom thick sheets is possible for small-scale experiments. With our current state of technology, creating a 1-atom thick sheet of anything on a large scale is not possible. A way needs to be invented to mass produce or manufacture 1-atom thick sheets in an economical way before we will see this type of technology used in consumer products. It is highly probable that companies will spend a lot of money on research and development to be able to manufacture carbon nanotubes, since researchers have already discovered that carbon nanotubes form the highest tensile strength material. A high tensile strength material like nanocarbon tubes would make for a good material to use as building blocks for future further advancing technologies. Nanotechnology looks at materials on an incredibly small scale, at the atomic level. Materials at the nanoscale level behave very differently and take on different characteristics. Technology at the nanoscale is more highly focused on the behavior of materials used. The applications of nanotechnology can be used to modify our current technology to raise the standards of entertainment as well as make practical applications. As computers need more processing power, the current manufacturing process bumped into the limits of silicon that is currently being used. A new way of making computer chips will be created. Carbon is likely to replace silicon in computers. Carbon has its own properties that make it advantageous. Do you find nanotechnology interesting? Share this article with your friends and talk about what video games you want to play and what images do you want to project on the walls of your living room. Thank you so much for taking the time to watch this episode. I hope you found it interesting. And if you did, then I would certainly encourage you to subscribe to my email list at grabyourfreegift.com/crystalo, CRYSTALO. And what it is every week I send out a blog post and an inspirational quote as well as occasional bonuses. And I encourage you to create a folder in your inbox of !career conversationalist. This way you can easily find and replay episodes that you found the most interesting or that you know you're going to need to access again in the near future. I'd also like to take a quick moment to thank Google for the technology that has allowed this to be made. Right now, this episode is being recorded on Google Hangouts. And if for some reason you're not able to watch the live episode, then please go ahead and watch it on YouTube, which will make it available for a replay later. Thank you so much for your time, and I look forward to our paths crossing again soon. Take care.